Sometimes we shouldn't turn the tape off in between.
Well,
Come up with all these
gotta
other
make sure that
things
we
to
did
say.
turn it off.
Right.
Right.
Okay, so for number 20, how specifically water molecules line up when placed between charged plates. I have a plate,
I have a plate.
and they're different charges. So if we had water molecules in between here, and we know that water molecules have an end that's a little bit negative and an end that's a little bit positive. And if they're in between these positively and negatively charged plates, which would actually be hunks of metal, but work with us here, the water molecules are going to change their direction. They're going to line up all facing one way. Question is, which way is that?
So we have a stream of water coming down between two oppositely charged plates, and as soon as they get into the electric field here, how are they going to move? How are they going to react to this electrical field? Well, remember, water molecules are polar.
Right?
They're going to flip around because opposites attract, and they are all going to come flying past this stream, tipped this way, responding to this electrical field. They're all going to come through,
We have the positive plate over there,
tipped this way.
and the negative end is the oxygen end. We didn't draw the unshared pairs for sake of time. The hydrogen end is the more positive end. Positive's going to be attracted towards the negative plate. Negative side's going to be attracted towards the positive plate.
Right, and
Pretty simple.
we had some conversations and saw some demonstrations in class on it.
Right. Okay. Test hint number 21. How and why dipole interactions occur? Like, what causes dipole interactions?
Molecular polarity.
Right. So if it's dipole, it means two poles. So
poles.
a positive end and a negative end, like our water molecule and many, many others. And what happens when you get a couple of those near each other? Say an HCl near another HCl, or many, many of those molecules. This is a polar molecule. Is it going to line up like this with the more negative end next to the other more negative end?
No.
No, it is not going to do that. What's going to happen is that that's going to turn around, reorient, so that it's more like this. And excuse me for drawing just the structural formulas without the dots that we keep yelling at you to show your unshared pairs of electrons. So we got this more negative end attracting the more positive end here. And that's a weak attraction. It doesn't take too much energy to break that apart, but it also allows these molecules to kind of stick together a little bit and gives them some of the properties that we see.
Did you talk to your kids about the snowflakes? The way you usually do?
Snowflakes? Yeah, I probably will have done that by the time we see this.
Yeah, okay. Good.
Okay.
Number, where are we? 22. How and why hydrogen bonding occurs. Well, hydrogen bond, well,
We keep erasing the things we need.
right.
So hydrogen bonding happens most commonly.
Well, and we did talk about this in class, that hydrogen bonding is kind of a misnomer. It's a very strong intermolecular force of attraction. It is not a bond per se. The hydrogen on one molecule is not sharing another imaginary set of electrons it doesn't have with another nearby molecule. It's a very strong attraction.
Attraction.
Yeah.
So here's my model of water molecules, and these happen to be held together magnetically, but they form, they attract and stick together pretty well,
Yeah.
which is why we have all the wondrous properties that we do for water. But it isn't a true bond. Keep that in mind. It's a really, really strong attraction, like they really, really like each other, but they're not actually bonded.
Right. Very strong attraction that forces these molecules to orient themselves, especially when they slow down.
Right. And freeze and make pretty crystals.
Yes.
Okay.
23.
23. What kind of bonding is involved in the formation of network solids, and how can this kind of bonding be broken, right? Yeah. How this bonding can be broken.
Yes.
Girls love the network crystalline solids.
Oh,
Diamonds.
diamonds.
Yes.
And-
And sand, but
Yeah.
whatever.
Yes. So these are intermolecular forces of attraction that actually produce in network covalent solids, they actually produce fracture planes within the crystal structure.
Right.
Where these molecules actually break apart from each other. Kind of like with graphite.
Oh yeah.
You get sheets of carbon, and when you write with a pencil, you're literally peeling off sheets of carbon and laying them down on the paper.
Right. We have a couple images of the tetrahedral bond in a crystal structure posted on Moodle. Take a look at that. It's basically tetrahedrons attached to other tetrahedrons and so on and so on and so on. And it builds up and it forms that substance that's kind of in between the properties of ionic and covalent. So it's got a little bit stronger attraction and bonding and higher melting point like our ionic solids do, but yet is still made of all nonmetals, so it's covalent. Right.
There's probably going to be a lot of double bonding in there. Give it that extra strength.
Okay, number 24.
24, how to calculate and compare percent ionic character. The electronegativities would be given, although everybody gets a periodic table.
Right, and it's right on there.
With their test, and it will be given to you twice then.
Right. So you'll actually have to do the calculation to answer this question. You should know that, hey, I think we did a pencast. Watch the pencast if you really don't remember how. And then you also need to know those ranges, and we put that in the pencast as well. So something that's like 0 to 5% ionic character, that's going to be a nonpolar covalent. 5 to 50% is going to be a polar covalent bond, and 50 to 100 tends to be ionic. Remember, it's not a hard specific cutoff point at that 50%. Take a look at what elements are in there too. If you're talking, if their question says something about a metal with a nonmetal, and even though you do the calculation and it ends up being like 47% ionic character, and you know that that's supposed to be in the polar covalent range, if it's got a metal in it bonded to a nonmetal, then it's an ionic bond. If it's two nonmetals, then take a look more closely at the ranges that you get after you do your calculation.
Good. 25, how to draw the correct Lewis structure for a specific tetrahedral molecule.
Right.
We're going to give you one and draw it. And it's actually going to be provided, we give you the picture.
Right.
You got to identify which one of those is tetrahedral.
Right. Now this is one of those questions where answer choice picture A might be answer choice C. So depending on the version of test you have, you need to make sure that you're choosing the correct letter on your test paper. And please do not embarrass yourself with things like this. I mean, what? No.
Right.
And if you're watching this and saying, well, what's wrong with that? Go back and study.
Yep. Start over. Number 26. The relative strength of the forces of attraction between molecules in a compound. So again, this is about intermolecular forces of attraction. There is a fantastic Brightstorm video with our friend Kendall on there about intermolecular force of attraction, and she goes through all of them.
Right. And compare ionic, something that's polar, something that's non-polar.
Right.
You've looked at this in labs and things many a time now. Hey, we're on the short answer.
Woohoo!
27. The test hint says the similarities and differences between sigma and pi bonds and how they form. So it goes back to the idea of overlap and what kind of overlap. Sigma bonds are the ones that form by direct overlap of orbitals that have been hybridized. So that's a true molecular orbital where they're blending. We've got that direct overlap, as opposed to a pi bond where we've got those unhybridized p orbitals to just kind of bump into each other, making the double bond or a triple bond.
Keep these short. Study these and plan out a response.
Right.
On that last chapter 7 test, when we were asking about ions, oppositely charged ions attracting each other, I was getting answers like
paragraph.
The history of chemistry as a science. Ions were first discovered by Mrs. Gregory in 1752, and don't focus, go back to your OGT training.
Right.
And here's the question, how many sentences is it going to take me to answer this question? What do I need to say?
Right. You need to
And
know
get it down there.
what a sigma bond is, what a pi bond is, how they form, why they're different.
Right,
You know, one stronger than the other, identify that, boom, you're done.
yes.
28.
28,
Justin says,
what a VSEPR is and how it affects the shape of molecules.
wasn't that a multiple choice question?
Probably,
Like 3 of them?
yeah. Yeah,
Okay.
I think it was over and over again.
So you need to be able to tell us what VSEPR stands for, and by the time you're done with this chapter, you should know that those electrons are trying to get far apart from each other, and that affects shape.
Absolutely.
Alrighty, 29.
What factor or factors affect the degree of polarity of a bond and what the difference is between the 3 common bond types?
Okay, so that's, we're going back to those ranges again when we talked about the
Right.
percent ionic character calculation. And again, look at the pencast. Is it an
Differences.
ionic bond, really far apart,
Metal,
high,
non-metal.
the metal, non-metal, high percent ionic character? Is it a polar covalent, where we've got 2 nonmetals pretty far apart on the periodic tables, big electronegativity difference, or is it nonpolar, and they're almost equal sharing?
Right.
And number 30, woohoo, how to identify the number of covalent bonds in a molecule, draw its Lewis structure, and write the molecular formula. This puts everything together. We will tell you we won't even tell you a substance, we'll tell you how many and what kind of atom, and you're gonna have to do all those things.
This question, if you get this question wrong, this is going to be a nightmare for you during test corrections.
Yeah.
Because this is
We will send you back
this
to redo it over and over and over until
This
you get
is
it right.
everything in the chapter boiled down into one question where you actually have to demonstrate and illustrate
Right.
what you've learned.
Right.
This whole test, or I mean this whole question in a college test would
Oh.
be one essay question,
Right.
and
50% of your test.
yeah, you'd
At
probably
least.
be expected to get at least 20 pages out.
Mm-hmm.
Yeah,
But,
but
makes sense.
not for here.
Right.
No.
Okay, so good luck, happy studying, watch the Brightstorm videos we have posted for you, watch the Pencast, look at those other resources, we've got some great simulations on the site, and be ready.
If you're watching this early,
Awesome.
awesome, ask questions
Right.
as these topics are coming up. Good for you for watching it early, but it's not enough just to have watched it early. Use it.